Hello guys, welcome to episode 2 of JS Pravah. In today's video, we are going to cover some basic topics which will build your foundation for JavaScript stronger. So let's get started. The first two things we are going to learn is call stack and memory heap. If you remember, in the first episode of JS Pravah, we learned about V8 engine of JavaScript, that how does it convert your code to machine language. If you have not watched that video, make sure to watch that also. So in that video, we saw how JavaScript works, but we did not talk about the memory management for a program. Whenever we write a program, there are functions, variables, objects, and many more things you declare or create into the program. But we have not talked about where these objects and variables are stored and at what place the line by line code is tracked. That is what is happening in the code. So there are two things. First is call stack and second is memory heap. So let's first learn about the memory heap. The memory heap, you can think about a large memory where you can create your variables, your functions, your objects, arrays, whatever the data you use into the program, that is all acquired into the memory heap. So either you are writing some function or you are declaring some variable. These all need some space on memory, and that is the memory heap which is being used into the declaration part of these variables. For example, if I declare a variable a equal to 10, that is going to be allocated into the memory heap and it will be available into the program with the name of a. That is how memory heap looks like. The second part is call stack. So whenever some function is running, that is pushed onto the call stack. In other words, if you want to say that I want to track my program, that how it is behaving, how it is being executed, so you need to take care about the call stack. Call stack is the place which keep tracks of your code line by line and which function is being executed. So I'll show you how this call stack works. So I can go to new tab of my Chrome and I can open the inspect. Then I go to the sources and here I'll create a new snippet. Let's name it test.js and I'll create a function, name it say hello, which takes a name and it creates a hello message and it returns the message. I'm going to create another function. I'll name it greet. This greet function will call the say hello function and finally it will be printing the greeting message. Now I'm going to call this greet function. Before running this program, I want to put a debugger over here just to track the code line by line. In the right hand side, we can see few things, but we are interested in this call stack because we are talking about the stack only. So currently you can see it is empty. Let me run the program. So our code is stuck here due to the debugger and you can see into the call stack there is an anonymous function. We will talk about this anonymous function later, but you can just think it is the global function which is executing our code. So we are not interested into this anonymous function. Let's move our code ahead. So we are at this line. This line is about to be executed. That is the greet function. And it is going to call this function. Let's move our code. So you can see in the call stack, there is a greet function over here. So what happened? In this program, when we call the greet function over here, it is going to push the greet function into the call stack. And that is our current execution. So we can track our current execution is into the greet function. So let's go into the greet function. So we can see in the greet function is again calling another function that is say hello. So let's move our program and you can see over the greet function, there is another function that is say hello and our code is currently into the say hello because the top function of the stack is always into the execution. So say hello is in the execution. So it is preparing a message. Let's run it. Then it's returning a message. And I want you to keep your eye here because we are about to return from this function, that is the execution of say hello function is about to finish. So as I click on this button, you can see the say hello function has been popped off from the stack. Now we are again into the greet function and we are printing the greet message. Let's move ahead. We are not returning anything from this function. So we are at the last line. It is a void function. Let's run it. So you can see as soon as the execution of this greet function finished, it popped off from the call stack again. And if we go to the console, you can see our message is being printed. So this is how the call stack works. But In order to access the variables, call stack have some reference into the memory heap. Let's see how does that look like. Suppose I have some functions into the call stack, and whenever they need to access some variables or functions or any type of object, arrays, anything that is part of a memory, they can directly access from the memory heap. And this is how call stack and memory heap works. Let's see an example into the code. Suppose I define a number that is 10, and this will be going into the memory heap. If I define a string, it will also go into the memory heap. If I define an object, let's say first name is code and the last name is Pravah, this will also go into the memory heap. Suppose I define a function which is returning a hello string, this will also go into the memory heap. But when we will try to call this say hello function, it will go into the call stack. And this is how the memory heap and call stack works. And it is not only related to JavaScript, this is the way it works in most of the programming languages. Let's move to the next topic, that is Stack Overflow. So as you know, our computer has a limited memory, limited resources. So there is a limited call stack and there is a limited memory heap. So as we saw earlier, call stack keep tracks of your function calls. But if you fill this call stack with lot of function calls, there can be a stack overflow. Now suppose if you keep calling the functions one inside another and they all are waiting into the stack, so there can be a chance that your stack is out of memory, and that condition is known as stack overflow. Because you know, any computer has a limited memory, limited resources, so there is a limitation on the call stack which depends on computer to computer. So let's see this situation with an example. So I'm going to write a function that is do stack overflow, and it is a recursive function. So it is going to call itself again and again. Let's call this function. And before running this program, I'm going to just put a debugger over here. So let's run this program and you can see our code has been stuck into the debugger. Let's move to the next line. So we are calling a function that is do stack overflow here. Let's step into this function and you can see into the call stack, there is a do stack overflow function waiting it to be executed. But if we visualize this function, we can see it is calling the same function again. So what will happen? If we move ahead, we can see there is another function which is coming inside this call stack. And if we keep moving this program, we can see the function calls are being added into the call stack again and again. So there will be a time when our call stack will be out of memory, and that condition is known as stack overflow. So if I remove this debugger, then if I run this program, you can see I got an error that is maximum call stack size exceeded. This situation is known as stack overflow. There is another important topic, that is garbage collection. As you know, to store our variables, objects and functions, we are using this memory heap. But we need to clean up this memory whenever we are done with our uses so that this memory can be used for other programs. And in JavaScript, this is done automatically by the JavaScript engine that we call as garbage collection. So what happens? Whenever JavaScript variables are allocated into memory heap, and when the execution is done, JavaScript engine frees up those memory in order to use it by other programs. Some low-level languages like C, C++, there we need to free the memory by ourselves only. There is no any garbage collector. However, they are memory efficient because the whole control is in your hand and you are freeing the memory as per your use. But what happens into the JavaScript? If we have declared some memory into a block, when the execution of that particular block will be ended, only then that memory will be releases. The next topic is memory leaks. Suppose I am having my call stack and these call stack are referring to some memory into the memory heap. Suppose our call stack is having three functions in the execution and they are referring some memory into the memory heap. Now when the first function will finish its execution, it will release the memory from the memory heap, and that's how it is happening. For the second function, which is holding two memory parts, it will again release these two memory parts. The last function will again release whatever it is holding. But we can see there is a one block left which is not having any reference. It might be a global variable which is not having a reference anywhere, but it is existing into the program. So that's where our memory leaks arises. So let's see this situation with an example. Now there can be some situations where you can run out of heap memory and that can lead to a browser crash or your program crash. For example, suppose I'm declaring an array, an empty array, and I have a function. Inside this function, I'm running an endless loop, and what it is doing, it is going to push only zeros into this array. When I'll call this function do crash, what will happen? It is going to stuck into an endless while loop and it will be keep pushing the zeros into this particular array. And since there is no any end of this loop, this function is not going to be ended until our heap is out of memory and program is crashed. The memory leak happens due to multiple of reasons, but these three are main reasons. We should avoid writing global variables because they are not destroyed as a block execution is finished. We should also avoid event listeners, and when we are using them, we should remove those event listeners once we are done with them. Using set intervals can lead sometimes memory leaks because when we will not clear those intervals, that can also lead to memory leaks. I hope you got some basic understanding for these topics, and if you are really enjoying this series, please let me know into the comment section. If you really learned something from this video, please hit the like button. Please subscribe to Code Prabha for more videos. Thanks for watching.